Okay, today's lesson is using Newton's second law of motion, which is that the magnitude of the force acting on an object is equal to the product of the mass of that particular object and the acceleration with which it moves. So, i.e., F equals ma, where F is the resultant force. It might be an idea, I think you do this in physics, to write that as the sum of F equals ma, just to remind you that you're working with a resultant force and not to confuse that F with the F we use for friction. A force of 1 Newton will accelerate a mass of 1 kilogram at a rate of 1 metre per second squared. So Newton is, the units would be kilogram meters per second squared. So it kind of makes sense to abbreviate that to a Newton. Just a quick discussion on weight. So we've mentioned weight a bit in our force diagrams. If you've got an object of mass m, and mass is measured in kilograms, then the weight acting on that mass is equal to mg, where g is acceleration due to gravity. So weight and mass mean different things. Weight is a force and mass is amount of matter, but we talk about weighing ourselves when we're actually finding our mass, so just be a little bit careful with that. So weight is equal to mg, so g is 9.8, where m is the mass in kilograms. So I'll go through a couple of examples of finding unknown forces. So first one, we've got an object of mass 2 kilograms. There's an unknown force y acting up. The weight is 2g acting down. And then we've got a force x to the right, 4 newtons to the left, that's meant to be horizontal, and acceleration is shown with this little double arrow, and the acceleration is 3 meters per second squared. So perpendicular forces don't affect each other. So we can start by resolving horizontally. So resolving horizontally, and that means I'm taking the positive direction to the right. So that's a positive force. 4 is a negative force, and that's the resultant force, will be x minus 4, and that's equal to the mass, which is 2, times the acceleration, which is 3. So the x is equal to 6 plus 4, which is 10 newtons. And then we can also resolve vertically. You could use F equals ma and set a to 0, but I would just think, well, there's no movement vertically, especially as it's accelerating in this horizontal direction. And so these forces are in equilibrium, and so y is equal to 2g, and 2 times 9.8 is 19.6 newtons. So I definitely would take your positive direction with the direction of motion. So here's another example. Four kg, got a force y. We've got another force acting down here of 20 newtons. Down here we've got the weight, which is 4g newtons, and x to the right, 80 to the left, and this one is going to be accelerating in this direction. So we'll take that as positive. It could be that it's decelerating. You could take this way as positive, and then this would have magnitude -2, this would be -18, this would be x, so it will have the effect of changing all the signs. But I take that way as positive. So what have we got acting horizontally? We've got 80 minus x is equal to the mass, which is 4 times the acceleration, which is 2. And so x is 72 newtons. And then to find y, we can resolve vertically. And again, it's in equilibrium. So anything acting up, which will be just y, is equal to the forces acting down. So 20 plus 4g. And so y is equal to 20 plus 4 times 9.8, which is 59.2 newtons. So I'm hoping that'll be enough examples. Remember to find the resultant force, and remember things like tension when you're drawing your force diagrams. So if you have a go at exercise 10C, that's page 164. So that's in the online textbook, which is the kind of brownie, I can't work out, it's meant to be purple brown, but it's kind of a brownie coloured book, which is the mechanics and statistics one. Questions 1 to 8, so they just get a little bit more involved as you work through.